Hello everyone, my name is Francis Xavier B. Bukoy II, and today our group will be discussing about wave energy. What is wave energy? Wave energy is created by the movement of the ocean surface. When the wave rocks the boat back and forth, it's doing work. This energy can be captured and used to produce electrical energy, and if harnessed properly, it can produce 10% of the world's energy needs. The three most common methods to harness wave energy are attenuators, overtoppers, and point absorbers. Wave energy is the transport and capture of energy by ocean surface waves. The energy captured is then used for all different kinds of useful work, including electricity generation, water desalination, and pumping of water.
Good day, everyone. I'm Ireneo D. Sarimogan, presenting the following: harnessing techniques, three basic system, and wave energy device. The harnessing techniques. In order to extract this energy, conversion device must create a system of reacting forces, in which two bodies move relative to each other while at least one body interacts with the wave. It's like a saw and wood thing. You need to rock the saw back and forth just to cut the wood. Waves retain energy differently depending on water depth. In this reaction, it loses energy quickly as water becomes shallow due to friction between the water and the seabed, and it loses energy slowly in deep water. Wave energy conversion designs are designed for optimal operation at a particular depth range. The three basic systems. Offshore device deals with swell waves. Nearshore device, maximum wave amplitude. And the embedded device built into shoreline to receive the wave-breaking waves. The difference between the offshore device and nearshore device are: offshore devices are moored to the seabed and transfer the generated electricity using subsea cables laid on the seabed, while the nearshore devices are predominantly fixed on the seabed. They capture wave energy nearshore and convert it to electricity in an onshore facility. And lastly, the embedded device. The embedded device is a shoreline device or wave energy device which are fixed to embedded in the shoreline and that they are both in and out of the water. The wave energy device. Wave profile device, they turn the oscillating height of the ocean surface into mechanical energy. Oscillating water columns. They convert wave energy of the wave into air pressure. And wave capture device. They convert wave energy of the device into potential energy. That's all, guys. Next, reporter, please.
There are three types of wave energy devices, one of which is wave profile device. This type of wave energy device uses the oscillating waves on the surface to rotate the shaft which is attached to the generator. There are two kinds of wave profile device. First is the point absorber. The point absorber is commonly used to power up navigation buoys that monitors and guides the ships and boats that passes its zone. There are 3 to 4 mooring buoys that is pulling the point absorber. That is to maintain the stability of the device, making sure it won't move to another place. The water buoy, as you can see, is being moved by the waves. A shaft is connected to the buoy as it moves up and down. The shaft is then connected to the generator, which is then responsible for generating electricity. The upper part of the point absorber is commonly seen as the navigation buoy. As you can see, its parts is dedicated to guide the ships and boats as they pass through the area. To make efficient use of the force generated by the wave, we need some force reaction. In other words, we want wave force on the float to react against another rigid body, like the ones we see. Here, is a suspended ballast plate, so it is anchored to the bottom of the sea. So this rigid body stays in place where the floating part moves in relation to the waves. Another kind of wave profile device is the wave attenuator. It is also known as the linear absorber. Its difference from point absorber is that the whole device is floating and it has a long cylindrical body composed of hydraulic ramps and is connected by a joint which is attached to a motor. It looks like a huge sea snake. As the wave passes through the hydraulic ramps, the joints in each section moves in a pushing and pulling manner. Now this movement drives the motor, which is connected to a generator inside the ramps. The generated electricity goes to a substation via subsea cable. Another type of wave energy device is the oscillating water column. So this type of wave energy device harnesses energy from the oscillation of seawater inside a chamber or hollow. As waves outside enter and exit the chamber, changes in wave movement on the opening cause the water level within the enclosure to oscillate up and down like a piston on a free space above the surface of the water, pushing it back and forth. The air is compressed and decompressed by every cycle of movement. The air is channeled to a wind turbine generator to produce electricity. The turbine rotates only on one direction regardless of which direction the wind is passing by.
The third device that harnesses wave energy or wave power is the wave capture device or overtopping power device. It's a shoreline to near-shore wave energy device that captures the movements of tides and waves and converts it into potential energy. Wave energy is converted into potential energy by lifting the water up onto a higher level. The wave capture device, or more commonly, an overtopping device, elevates ocean waves to a holding reservoir above sea level. This one is an overtopping converter. It allows well to deliver water over the top of the structure that captures it higher than the sea level, and then releases the water to drive a hydroelectric turbine similar to a hydroelectric dam. Ocean swells that would normally crash the shore or cliff are instead directed up a ramp to a water tank approximately 3 to 5 meters above sea level. The water is then released through a turbine back to sea level.
So I'll be discussing the advantages and disadvantages of wave energy. So first, let's discuss the advantages of wave energy. The first advantage of wave energy is the energy is free. No fuel needed and no waste is being produced. So every wave carries energy. So in order not to waste the energy, wave energy device is used and will harness the energy. So that device doesn't require or need fuel to be in operation. It only needs waves. The device also doesn't emit harmful gases or substances. So the second advantage, can produce great amount of energy. There are a lot of wave energy plants that are in operation and are commercially used. So the third advantage is being renewable. So waves are always in motion. So as long as there is sun and winds, waves can be formed. So the fourth advantage is environmentally friendly. So since it doesn't emit harmful gases or substances. So the fifth advantage is easily predictable or forecast. So waves is dependent on weather and winds. So as long as you can predict the weather and identify the strength of the winds, waves can be easily predicted and forecast. So the sixth advantage, it is a reliable source, which is true. There are a lot of wave energy plants that are commercially used and very beneficial to the society. The disadvantages of wave energy. So first disadvantage is suitable to a certain location. So the power plant or the cities that will benefit from the wave energy are those plants or cities that are near shores. So the second disadvantage is effect on marine life and ecosystem. So these machines or devices will disturb the seafloor. So the devices will create noises that will disturb the sea creatures and will affect the ecosystem beneath the sea surface. And it can be also harmful to some animals that will go near the device or machine. So the third disadvantage is dependent on waves. If there are no waves, this device is pretty much useless. There are waves that are not enough to drive the machines or the devices. There are also waves that are strong enough that will damage or destroy the machines or devices. The fourth disadvantage is need suitable sites. So you have to find site or location where the waves are strong enough, efficient enough waves to generate electricity or power. So the fifth disadvantage is weak performance on bad weather. This is also one of the disadvantages that will deteriorate the performance of the device when there is a bad weather. So the device couldn't perform to its maximum potential because of the weathers. The sixth disadvantages is maintenance and weather effects. So for the maintenance, I think the most disadvantage of the device, there's a lot of wave energy plant that cease operations because they couldn't maintain the plant, and the expenses to maintain the plant are very costly. And for the weather effects, when the weather is too cold, too hot, too stormy, that will it will cause an effect to the machines or device. That's all. Thank you for listening.